Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics and the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2018, first session, third exercise. The title of this exercise is Nature of a Lens. The document 4 shows a lens L. They mentioned the document 4, so now I can use this document. Its optical axis x prime x, its optical center O, its two foci M and N. Okay, here we must be very careful because they told me the two foci M and N. They didn't specify whether M is the image focus and N is the object focus or vice versa. Okay, an incident luminous ray SI and its emergent ray IR. So number 1, they are telling me L is a converging lens, justify. Notice that till this moment they didn't mention document 5, so I'm not allowed to use it. So all of my answers must be restricted to the graph and to the given text or the previous parts. Okay, so number 1, they are telling me that L is a converging lens, justify. In other words, they are asking me about the nature of the lens. And whenever the incident ray and its emergent ray are given, we can directly determine the nature of the lens. So this is the incident ray SI. And as we can notice that the emergent ray IR emerges toward the optical axis, and we know that always for a converging lens, the emergent ray emerges toward the optical axis. So let's say that since the emergent ray emerges from the lens L toward the optical axis, then L is a converging lens. So now in number 2 they are telling me let f be the focal length of L. 2.1 n is the image focus of L, justify. So we need to justify that n is the image focus. So we know that always for a converging lens, the emergent ray and the image focus are on the same side. IR is the emergent ray, and on the same side of IR we have the point N. Therefore the point M represents the image focus. So 2.1, let's say that for a converging lens, the emergent ray and the image focus are on the same side. Then N is the image focus. So now in 2.2 they are telling me deduce f. So in other words, we need to calculate f. They told me deduce because we need to use the part just previously before. In 2.1 we have determined which point represents the image focus. So now we know the position of the image focus and we already know the position of the optical center. So we can calculate f graphically using its definition, which is given by the focal length is the distance from the optical center to the image focus So always, whenever we need to calculate the focal length, we always start by writing the definition. And now let's calculate the focal length. So the focal length is the distance from the optical center, which is the point O, to the image focus, which is the point N. And we don't forget the bar, because this distance may be positive or negative. So now the focal length is equal to O n bar, which is the distance from the optical center to the image focus, the point N, which is in the same direction of the positive x-axis. For this reason, the focal length in this case is positive. And now we count the number of divisions between O and N. We have one division. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. And this will give me 5. Since the scale is in centimeters, then the value of f will be in centimeter. Always, all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Okay? So done for part 2.2. Now we have reached part 3. They are telling me reproduce on the graph paper the figure of document 4. So number 3, we need to reproduce the figure. Okay, so notice that here they didn't indicate the direction of propagation of light, but from these arrows we can know that the direction of propagation of light is from left to right. As a first step, whenever we need to reproduce, we always start by drawing the optical axis at the center, having the same direction of propagation of light. Then we place the lens L perpendicular to the optical axis at the center. Now we know that the lens L is a converging lens, we use the correct symbol. And the intersection between the optical axis and the lens L is the optical center O. Now the point M is located one division in front of the lens. And N, which is the image focus, is the symmetric of M with respect to O. Okay. Now the point S is located 1, 2, 3, 4 divisions in front of the lens and 2 divisions downward. So 1, 2, 3, 4, 1, 2. This is the point S. Now the point I is located 1, 2 divisions on the lens upward. So SI is the incident luminous ray. Okay. IR is the emergent ray hitting the optical, passing through the optical axis at this point, 2 divisions behind the lens. So this is the emergent ray IR. And we don't forget arrows on light rays, incident rays as well as emergent rays that indicate the direction of propagation of light. This is R. Moreover, the scale along the x-axis is given by 5 centimeters. So this is it for part 3. Now in part 4, they are telling me trace with the justification the path of a luminous ray issued from us and parallel to the optical axis of L. So we need to trace and justify an incident ray issued from us and parallel to the optical axis. This is a ray issued from us and parallel to the optical axis. We know that always incident parallel ray is related to the image focus. Here in this case, the image focus is the point N. Therefore, this ray will emerge passing through the image focus. This is the tracing of the ray. Now let's justify its path. So an incident ray issued from which point? The point S, issued from us. Parallel emerges passing through the image focus. Now in number 5 they are telling me what does the point of intersection of the two emergent luminous rays represent. Always the intersection of the emergent rays is the image of the object. Okay, so this point represents the intersection of the emergent rays. These emergent rays are coming from these incident rays that are coming from the point S. Therefore their point of intersection, which is here, represents the image of S, which is given by S prime. So this is S prime. Then let's say that then the image S prime of S is the intersection of the emergent rays. Okay, now in number 6 they are telling me document 5 represents, they mentioned the document, so now I can use the document. Two different lenses, specify which lens A or B corresponds to L. First of all, we know that the lens L is a converging lens. In order to determine which of the lenses corresponds to L, we need to determine the nature of each lens. Okay, so notice that the lens A is thicker at the center and thinner at the edges, and this is known as a thin edge lens, which is a converging lens. So this lens is a converging lens because it's thicker at the center, whereas the lens B is thicker at the edges and thinner at the center, and this is known as a thick edge lens, which is a diverging lens. So the lens A corresponds to L because they are of the same nature, which is a converging lens. Then let's say that since a converging lens is thicker at the center and thinner at the edges, and this is known as thin edge lens, then A corresponds to L. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.